constant function is a type of function where every input from the domain is mapped to the same output in the codomain, regardless of the input value. In a mapping diagram, this means that all arrows from the domain elements point to a single fixed element in the codomain. For example, for f of x equals 3, every input value, no matter what, maps to the output 3.
A vending machine is programmed so that no matter which button a customer presses, it always dispenses a bottle of water. Which of the following best describes this behavior in terms of a constant function from button presses, domain, to dispensed items, codomain? This means that different inputs, button choices, always result in the same output, illustrating the definition of a constant function.
Please hold on, let me say something here. This is not an identity function. Please take a look at it, because what the question says is that which of the following best describes this behavior in terms of a constant function from button presses, which is the domain, to the dispensed item, which is the codomain. The reason why I'm saying this is this. Pay attention. A constant function maps every input to the same single output. So whatsoever, any value you pick from the domain, what you will get is the same thing in the codomain, whatsoever, no matter what you press. But in this case of vending machine now, what you will notice is that all button presses, which we can refer to them as input, they will result in the same item, which is the bottle of water. So you can pick the correct option now.
Even and odd functions describe specific types of symmetry in mathematical graphs. An even function satisfies f minus x equals f of x, meaning the graph is symmetric about the y-axis. Both sides mirror each other. An odd function satisfies f of minus x equals 9 of f of x, meaning the graph has rotational symmetry about the origin. If the graph is rotated 180 degrees around the origin, it looks the same. These properties apply over symmetric domains.
A company tracks delivery time delays for vehicles traveling east and west from a central hub. The delay function, f of x in minutes, depends on distance x from the hub. It is observed that a vehicle delayed by 10 minutes at +5 km east, a vehicle also delayed by 10 minutes at -5 km west. What can be said about the function fx representing the delay? This means the function gives the same output for equal distances in opposite directions, suggesting it is an even function where f of x equals x.
For this particular question, let's first of all notice something like symmetric about the y-axis. If you look at the question very well, the question says that the vehicle delayed by 10 minutes at 5 km to the east, and the same vehicle also delayed by 10 minutes at -5 km to the west. So the function seems to be even. Yes, it is. Because it's obvious that there is a kind of reflection about the symmetric axis, in the sense that this reflects symmetry about the y-axis, which is the defining feature of an even function. So which of the following option is correct?
At a university, a student tracks their weekly net balance of expenses and income using a function f of x, where e is the number of days from midweek Wednesday. Positive values of f of x represent income, and negative values represent expenses. The student notices that f of minus x equals minus f of x, meaning that their financial activity on Monday is the opposite of that on Friday, and so on. What does this tell us about the function f of x? This pattern shows that the function is symmetric about the origin, which is a key characteristic of an odd function.
A periodic function is one whose values repeat at regular intervals along the input axis. This means that for some fixed value t, f of x plus t equals fx for all x. In mapping terms, multiple distinct inputs map to the same output repeatedly. Common examples include f of x equals sine x and f cos x, both with period 2 pi, and tan x with period pi.
A university student records the number of students entering the campus cafeteria every hour over several days. The data shows that the number of students follows a repeating pattern. It increases before lunch and dinner and decreases afterward, following the same trend each day. Which of the following best describes the function modeling this situation? This scenario reflects a function whose outputs repeat at regular time intervals, capturing the essence of a periodic function.
A piecewise-defined function assigns different formulas or rules to different parts of its domain. This means the function behaves differently depending on the value of the input. In a mapping view, inputs from various domain intervals are directed to outputs using distinct expressions. Each segment of the domain has its own rule for determining the output, allowing the function to model situations with changing behavior across different input ranges or conditions.
A university gym charges students based on the time they spend using the facility each day. Free for the first 1 hour, it's $500 per hour for the next 2 hours, sub $1,000 per hour beyond 3 hours. Let f of x represent the total fee in Naira a student pays for using the gym for x hours in a day. Which of the following best describes the nature of the function fx? This setup uses different cost rules depending on how many hours the student spends, which reflects the structure of a piecewise-defined function.
A composite function involves combining two functions so that the output of one becomes the input of the other. It is written as f plus g x equals fgx, meaning you first apply function g to the input x, then apply function f to the result. In a mapping diagram, the input value moves from the domain through function g to an intermediate set, and then through function f to the final codomain.
A university student uses an app to calculate the total time needed to commute to campus. The app first uses function gx to convert the distance x in kilometers into travel time based on traffic, and then applies function ft to estimate the energy burned in calories based on that travel time. If the student wants to calculate calories burned based on distance, what kind of function describes this process? This scenario represents a composite function because the output of one function becomes the input of another, linking distance to energy burned through an intermediate step.
An inverse function undoes the operation of the original function. If fx equals y, the inverse function satisfies f minus 1y equals x. In mapping, this means that the direction of the arrows is reversed. Outputs become inputs, and vice versa. True inverses only exist for bijective functions, as they must be both injective, one-to-one, and surjective onto, ensuring a unique, reversible mapping.
A university bookstore uses a function f of x to calculate the final price, y, of a textbook after adding tax to its base price, x. Later, a student wants to know the original base price before tax from the final price. Which function would the student need to use to determine the original price? To find the base price from the final price, the student would need to reverse the process, which involves using the inverse function.